Imagine this, flying from Tampa to China, Australia, or anywhere else in less than an hour. Flight engineers at the University of Central Florida are figuring out the secret to safe hypersonic travel. For decades, humanity has dreamed of reaching the stars, but the vast distances to even our nearest stellar neighbors seemed impossible to conquer. Interstellar travel, once confined to science fiction, appeared centuries away, until now. NASA has shocked the world with an announcement. A lightspeed engine capable of interstellar travel might soon become a reality. This breakthrough has ignited excitement, skepticism, and debate across the scientific community. So, what is this lightspeed engine? How does it work, and what could it mean for humanity's future? To understand, we must first explore the challenges of interstellar travel and the revolutionary solutions scientists are developing. The greatest hurdle is distance. Our closest star system, Proxima Centauri, is 4.24 light-years away. Traveling there with today's fastest spacecraft, the Parker Solar Probe, at 430,000 miles per hour would take over 6,700 years. Clearly, achieving such a journey requires a propulsion system far beyond chemical rockets, which are limited by fuel efficiency and mass constraints. Enter NASA's Lightspeed Engine, a groundbreaking concept that bypasses the need for conventional propellant. Instead, it leverages cutting-edge physics, including Einstein's theory of relativity, to achieve unprecedented speeds. Central to this technology is the warp drive. Inspired by science fiction but rooted in real physics, the concept was first theorized by physicist Miguel Alcubierre in 1994. It involves bending space-time, compressing space ahead of a craft while expanding it behind, creating a warp bubble that moves the spacecraft without violating the laws of relativity. Previously, warp drives seemed purely theoretical, requiring exotic matter with negative energy density, something never observed in nature. However, recent advances in quantum mechanics have brought this idea closer to reality. NASA scientists are exploring phenomena like the Casimir effect, which produces negative energy between two closely placed plates in a vacuum, and quantum vacuum fluctuations, where virtual particles appear and vanish in empty space. These breakthroughs could enable the creation of the warp bubble. Additionally, NASA is drawing from plasma physics and electromagnetic propulsion. Plasma, a state of matter consisting of charged particles, can be manipulated with electromagnetic fields. Technologies like the Variable Specific Impulse Magnetoplasma Rocket, VASIMR, have demonstrated the potential for high thrust without traditional fuel, paving the way for the Lightspeed engine. Powering such a revolutionary engine demands immense energy. NASA is investigating antimatter as a potential source. When matter and antimatter collide, they annihilate each other, releasing tremendous energy as described by Einstein's equation. equals mc. A small amount of antimatter could generate the power needed for interstellar travel. NASA's developments mark an exciting leap toward a future where the stars are within our reach. While challenges remain, this lightspeed engine could turn science fiction into humanity's greatest achievement. Antimatter is incredibly rare and hard to produce. Current methods, like particle accelerators, are costly and inefficient. To tackle this, NASA is teaming up with global partners and private firms to explore new ways to generate and store antimatter. One promising method involves using magnetic fields to trap antimatter particles and prevent them from interacting with matter. The implications of NASA's Lightspeed engine are groundbreaking. For the first time, humanity could explore star systems within a single lifetime. Imagine reaching Proxima Centauri in just a few years instead of thousands. This could revolutionize our understanding of exoplanets and the search for alien life. Beyond science, this engine could reshape humanity's future. Interstellar travel might address overpopulation and resource scarcity by enabling colonies on habitable planets. Such technology could also inspire global cooperation, much like the Apollo program during the space race. However, significant challenges remain. While the theory behind the engine is solid, practical implementation demands advances in material science, quantum computing, and energy generation. Overcoming these hurdles will require major investments and a collective effort from governments, corporations, and international organizations. Ethical concerns must also be addressed. We need to explore space responsibly, protecting extraterrestrial environments and respecting any life forms we encounter. The development of interstellar technology must prioritize inclusivity, sustainability, and collaboration. Despite these challenges, NASA's announcement marks a turning point. It showcases human ingenuity and the enduring drive to explore. As Carl Sagan once said, "Somewhere, something incredible is waiting to be known." This isn't just about science or technology, it's about redefining humanity's role in the universe. The road ahead will be tough but filled with discovery, wonder, and hope for a brighter future. At the heart of NASA's Lightspeed engine lies a key challenge: breaking the speed limit imposed by Einstein's theory of relativity. According to relativity, nothing with mass can reach or exceed light speed because the energy needed becomes infinite. This has long limited our ambitions for interstellar travel. However, advances in quantum mechanics and theoretical physics suggest faster-than-light travel might be possible. NASA's engine bypasses relativity's limits by manipulating spacetime. Using a warp bubble, it compresses space ahead of the craft and expands it behind, letting the craft surf through space without breaking the speed of light. This relies on negative energy, a real but elusive phenomenon tied to quantum vacuum energy. Generating and sustaining negative energy at the scale needed for a warp bubble is one of NASA's biggest challenges. Recent breakthroughs in quantum field theory and phenomena like the Casimir effect offer new possibilities, but turning theory into practical technology remains a monumental task. Building a Lightspeed engine is both a theoretical and engineering challenge. The required materials, energy, and computational systems are far beyond today's capabilities. Yet progress continues on several fronts. Creating a warp bubble requires materials that can endure extreme gravitational forces, heat, and radiation. NASA is heavily investing in metamaterials, which can manipulate electromagnetic waves. Graphene, a strong, lightweight, and conductive material, shows promise for components of a Lightspeed engine. The energy needed for faster-than-light travel rivals that of a small star. Traditional fuels fall short, so NASA is exploring nuclear fusion and antimatter reactions. Fusion offers nearly limitless energy, while antimatter annihilation produces immense power, though safe production and storage remain major hurdles. Warp drives demand vast real-time data processing for navigation and bubble control. Quantum computers, leveraging quantum mechanics, could handle these tasks. NASA is collaborating with pioneers to optimize warp bubble stability and automate spacecraft decision-making. The Lightspeed engine isn't just a technological leap, it poses profound questions about humanity's future and values. Interstellar travel could mirror the transformative age of discovery, opening new frontiers for science, culture, and economics. Industries around interstellar travel would emerge, driving innovation and international competition. However, reaching other star systems comes with obligations. How should humanity interact with extraterrestrial life or protect alien environments? Policies like planetary protection must evolve to prevent contamination and ecological harm. The enormity of this endeavor demands international teamwork. A united pursuit of interstellar travel could foster global cooperation and even alliances with extraterrestrial civilizations, pooling resources and knowledge. NASA's Lightspeed engine symbolizes humanity's relentless pursuit of knowledge. While challenges abound, the potential rewards, access to new resources, solutions to planetary threats, and answers to cosmic mysteries, are immeasurable. Interstellar travel could transform our understanding of existence and secure humanity's survival through the colonization of other worlds. As Carl Sagan said, "The cosmos is within us. We are a way for the universe to know itself." Humanity is taking its first steps toward the stars. The journey will reshape global perspectives, solve resource scarcity, and redefine competition. But without ethical oversight, it risks repeating past mistakes of colonization, exploitation, and conflict. The stars are calling. Will we rise to the challenge? Throughout history, exploration has expanded both our physical and cultural horizons. Lightspeed travel would take humanity beyond anything even the most advanced telescopes can show us, profoundly shifting our worldview. Discovering microbial or intelligent life could challenge long-held beliefs about humanity's uniqueness or reinforce the idea that we are all part of a cosmic tapestry. Art, literature, and media would evolve, drawing inspiration from interstellar journeys. A Lightspeed engine wouldn't just reshape our physical reality, it would spark a new era of creativity. The economic impact of interstellar travel would be staggering. Lightspeed engines could create industries we can't yet imagine, similar to how the internet transformed commerce and culture. Mining, energy, and tourism could all be revolutionized. Interstellar tourism, while initially for the wealthy elite, could become mainstream as costs decrease. Resource extraction from other planets could disrupt economies. What happens if vast quantities of rare metals are discovered? Could this lead to greater inequality or newfound abundance? Colonization of a habitable, uninhabited planet would bring its own dilemmas. How can we ensure fairness and sustainability in such efforts, avoiding humanity's history of exploitation and environmental destruction. Principles of justice and respect for alien worlds must guide interstellar colonization. The journey to interstellar travel is daunting, but its rewards, new knowledge, cultural growth, and a greater understanding of our place in the universe, could define the next chapter of human history.